I'm Bruce Berriman, and I'm going to give you a demonstration of a notebook that shows you how to identify those protostars in the Rho Oph dark cloud that have been measured with any of the instruments at the Keck Observatory. So briefly, the notebook uses the new COA data discovery service to discover all the Keck observations of the Rho Oph region. We're going to acquire a table of protostars from VISIA and then overlay them on a pre-computed Spitzer IRAC mosaic that we acquire from the Infrared Science Archive. The final visualization at the end is going to look like the image at the top right-hand corner of the screen. So let's get started. To begin, you do need to install these packages here. The notebook's been tested on Python 3.10, 11, 12, and 13. We haven't tested it on earlier versions, so we don't know if it runs on any of them. Right, let's do the setup. We import the packages we need and also define a general utility function for retrieving URL to a file, which we'll be using later on. Right, now we set up the region parameters. In this case, it's Rho Oph with a radius of 1.5 degrees for the search radius, and we are setting up the workspace. So now we've got the setup done. We can do an object lookup through SiMBAD, and the output shows you the RN deck of the central region of Rho Oph and tells you where the workspace is. Right, so the next step is actually searching the Keck Observatory Archive holdings that we do directly with the data discovery service through a URL. It requires an RA, a deck, and a radius in degrees to run. The service will support a time range, but that's not used here. Now, the results are all written in the workspace as IPAC column delimited files, and in this case 11 Keck instruments have made observations of Rho Oph. So this is now run. You get a listing of the counts of all the instruments, and individual tables are then written to the workspace. Sometimes you have to be a little bit patient in waiting for these. For instance, NIRSpec took a little more time than the others because it has over 21,000 observations in this region. Can verify that all the tables we think are there are actually in the workspace, and then we can go ahead and acquire a list of protostars. We're going to do this with VISIA's VO compliant table access protocol server. We're going to download 38 protostars that are listed in table 3 of 218 gigahertz OBS of embedded protostars in Ophiuchus, which is a paper published by Lindbergh et al. In 2017. You can see the locations of these sources along with a luminous source S1 shown as a blue ring. If you're interested in the paper, we have a link there, and you can also go to the VISIA page. Right, so that is done. Everything is successfully downloaded to the workspace. Now we download the Spitzer IRAC mosaic. You can substitute any image you like here. You can upload something for your own local directory, or you can go to another archive and access your favorite image from your favorite mission. Please be aware that sometimes these images can get big, and so you do need to be a little bit patient in waiting for the download to complete, which is the case here. Okay, so that's now successfully downloaded. The image is pretty big. It's 4,000 by 4,000 pixels, so it's convenient just to shrink it down to make the presentation quicker and easier. Again, we can verify that all the files we expect are downloaded into the workspace, which they are. Now we come to the fun part. We need to define the layout of the visualization display. So this is where you have to be a bit careful. We do this with the COA Viewer application that simply is a React component that lets you visualize data that you've downloaded into the workspace. There are 3 ways of setting up the parameters of the image display, which will include things like overlays, colors, symbol sizes, and so on. And That layout will be written into a JSON structure file called layout.json, which you'll find in the top level of the workspace. Now, there are three ways to go about doing this. One is let CoViewer create one for you when it starts up. This is kind of taking a guess, and it's often not suboptimal. You can do it. We don't recommend it. Alternatively, we'll do what we do here, which is construct the workspace, construct the layout in the notebook, and then write it to the workspace. Finally, you can use the CoViewer app to do some editing of fine-tuning of details with pop-ups if you want to do that. So let's define the JSON layout, which has now been written. And now we get to the fun part. We're going to run the visualizer. And we can look at it by activating this link here. So you see that there are tables of the metadata for each of the instruments. The tables are active. You can sort them and filter them as you wish. The color coding is the same color coding that's used in the visualization image itself. Now, the visualizer has the usual selection of features. You can zoom in and zoom out and so on and so forth. One thing I do want to show you is overlays and how you can change them. For instance, let's have a look at the protostars and the NIRSpec data. So we have to deactivate the rest of these data, these tables, which we do like this, and then we click close, and it brings up the NIRSpec observations superposed on positions of the protostars. All right, so that is pretty much everything to it. I hope you give it a try. If you have features you'd like to see added or have comments, please get in touch with us at the help desk. Thank you very much for listening.